Hey, good morning. Welcome to
MathForKids number 152.
MathForKids number 152. Today we are going to do a movie just like we did on MathForKids number 150 and MathForKids number 152 about Mars orbiting the sun, and we're going to try to figure out how fast Mars is going, right?
Yeah.
Okay, sometimes Mars gets hit by asteroids though, right?
Yeah.
Do you know what that's like when that happens?
Meteor.
BAM! Something comes flying in and hits Mars.
It's the light.
It hits the lights. Okay, so now when we did this movie about the Earth and Jupiter, do you remember how fast the Earth was moving?
It was like 67,000.
Yeah, 67,000. That might not be exactly right if you look that up, but if you go watch MathForKids149, that's what we found by doing some of our approximating, right?
Yeah.
Okay, and then Jupiter was moving. Do you remember?
Jupiter was like 29,000.
Yeah, 29,000 miles per hour. So again, that might not be exactly right. I think this one is a little more off. I think it's more like 26,000 actually for Jupiter. But we're making approximations, so we get about how fast they're moving. Okay, so today we're going to look at Mars. Just like before, we're going to pretend the orbit is a circle.
It's really an ellipse.
And it's really an ellipse. Now, why is it important that we're pretending that it's a circle?
Because we don't know how to calculate the circumferences of ellipses.
Right, we don't know how to calculate the circumferences of ellipse. Let me just write up here. Earth, 67,000. And Jupiter. So it'd be interesting to see if Mars is faster or slower or what. Is Mars farther away than Earth from the sun or closer?
Yeah, it's farther.
Is it farther away than Jupiter or closer?
Closer than Jupiter.
Closer, okay, so it's in between. Okay, so we looked up on the internet and we found that the distance that Mars is from the sun is 141,634, I think 720 miles, but that's too cumbersome of a number. So what's a good approximation?
140.
140 what?
140 million miles.
140 million miles. Okay, so Mars is about 140 million miles from the sun, and it takes, do you know how long it takes Mars to go around?
Like 687, something.
Yeah, we looked that up, and it's 687 days. How is that in relation to the Earth?
It's almost like 2 years.
It's about twice as long. So 687 Earth days, we mean. Earth days.
Not Mars days.
Not Mars days. I didn't look up how.
Mars days are similar to Earth days.
Are they?
Yeah.
Okay, I didn't know that. Okay, so what do we do to figure out how fast Mars is moving?
Well, we need the distance and the time.
Okay, so we have speed equals distance divided by time. This is the formula we're trying to figure out. So ultimately we were going to try to figure out miles per hour, but we don't have miles per hour quite yet. What's the distance that Mars travels?
It's the circumference.
Okay, that's why it's important that we're pretending this is a circle, even though it's not quite a circle. And how do you figure out what the circumference of a circle is?
It's 2 pi times the radius.
Okay, so the distance here is 2 pi times 140 million miles over 687 days. And this is nice because this is a distance divided by time. So we're going to get miles per day, and then we can convert that into miles per hour later, because how many hours are there in a day?
You just multiply by 24. Well, 24 hours are in...
You divide by 24.
Yeah.
Yeah. Yeah. Because if you go 1 mile in a day, you don't go 24 miles in an hour, right? If you go 1 mile in a day, how far do you go in an hour?
It's 1/24.
1/24 of a mile, right? Okay, so we got to figure out first 2 pi times 140 million.
It's 180 million pi.
Okay, which is 180 times pi. What is pi?
It's 2 pi is like 3.1.
Okay, 3.14.
4.
So what I'm gonna do it like we did it in the other movies, and I'm gonna say that 2 pi which is 6.28, which is, we're going to say this is about 6.3. Okay? So instead of calculating 180 times pi, I'm going to calculate 6.3 times 140. Okay? Okay, which is, we're going to do 6 times 140 and 0.3 times 140. But we can just do everything times 14, right? To make our life easier?
And just add 0.
And then just add a 0. So what is 0.3 times 4?
Is 1.2.
1.2. What is 0.3 times 10?
Is 3.
3. Okay. What is 6 times 4?
Is 24.
What is 6 times 10?
Is 60.
60. Okay. So what does this add up to?
It adds up to 88.2.
Right, so this is 88.2. So 14 times 6.3 is 88.2. So what is 140 times 6.3?
Just multiply that by 10.
Which is?
Just 882.
882. So the circumference is 882 million miles. So now we just have to compute 882 divided by 687 days. Yowza. Okay? So, let's see. 882 divided by 687. So how many times does 687 go into 882? Once. 687. So what is 882 minus 687?
200. It's 195.
Right, 195. Then I bring down a 0. Ooh, 687 into 1950.
Let's try. How about 3?
How about 3? I think that'll be right. Because 3 times... Oh, it might not be, actually. Let's see. 687 times 3 is 21, 240, and 1800.
It's too large.
Too large.
It has to be.
So it's going to have to be 2. My mistake. What is 687 times 2?
We get 14, 160, and then 1200. So this is, it's 1374.
Okay, so what is 1950 minus 1374?
600 minus 20 minus 4
So 600 minus 20 is?
is 580.
Minus 4 is?
It's 576.
Okay, so now we have the tricky one. 687 into 5760.
How about, let's try 8.
Okay, let's try 8. Not a bad guess. 687 times 8 is 56, 640, and 4800. So that's 5496. Is that within 687 of that?
Yeah, it's
Yeah.
5.
Yeah, it's very close. So this is about 1280000. Okay, that we're just going to stop there after 3 digits, okay?
Okay.
So this is, now what are our units here? 1280000 miles
Miles per day.
per day. So that's how fast Mars moves. 1,280,000 miles per day. Okay, how do we get that into miles per hour?
Just divide by 24.
Okay, now we have to divide by 24. So let's do that. Okay, 24 into 128 is?
24 times 5 is 120.
That leaves us 80. 24 into 80 is?
3.
3.
72. 70. It's gonna be 3 again.
It's going to be 3's for the rest, right? So we get approximately 53,000. And what are our units here?
miles per hour.
Miles per hour. So that's interesting. So Mars goes about 53,000 miles per hour. So Earth is inside of Mars. The orbit of Earth is inside the orbit of Mars, and the orbit of Jupiter is outside, right?
Yeah.
But Jupiter goes slower. Mars goes a little faster, and Earth goes the fastest. Isn't that interesting?
Yeah.
Pretty neat. Okay, so we figured out, we calculated that Mars goes about 53,000 miles per day. So that's it's a really neat use of geometry, right? Where did we use geometry here?
The circumference.
Yeah, we just figured out what the circumference was. And then we used our speed formula. And then we had to rely on some astronomers to tell us how far away it was. Because we didn't know that, right? That's not geometry. Somebody actually had to go measure that.
I read it.
You read it? How do you think they measure that? Think they get one of those measuring tapes that you pull out and it goes to 140 million miles? Pretty neat. And they figured out how long it takes to go around. So there we go, 53,000 miles. I think that's pretty close to being right, by the way. So, good job. Good job.